Okay, this lesson will be about functions and different types of functions and how to look at them. So first of all, you know that in order for an equation to be a function or a graph to be a function, that every x in the domain has to map to exactly one y in the range. The easiest way to tell if it's a function is to look at the graph and see if it passes the vertical line test. The vertical line test is where it crosses. You have to be able to draw a vertical line every single place on the graph, and it can only cross the graph in one point. If it crosses the graph in more than one point, anytime you draw a vertical line somewhere, even if it's just one spot, then it is not a function. Okay? So that, first of all, is the way to determine if something is just a regular function. Then there's a special kind of function called a one-to-one function, and that's where every x has to produce only one y. And in that case, it passes the horizontal line test. And so we will kind of look at whether things are functions and one-to-one functions here in a minute. Okay? So here's a graph. The question, first of all, is it a function? Okay? And so if it's just a function, you want to see if it passes the vertical line test. So I move my vertical line, and I want to be able to draw that anywhere. And I see it's hiding behind my graph. But I want to be able to draw that anywhere. And of course, if I were to draw a vertical line right here, it would not pass the vertical line test. So this is not even a function in the first place, and because it's not a function, it certainly can't be a one-to-one function. Okay, so it has to be a function first, and then you determine if it's one-to-one or not. Okay, here's the next one. Is this one a function? Of course, I'm going to draw my vertical line anywhere. And the key point here that maybe people have in question is if your vertical line is right here. And that would be the questionable one. This, of course, is an open circle right here. So technically, the line is not hitting, the vertical line is not hitting that spot because it's open. That point is not included. It is included here, but that's okay because then it only technically hits one spot here, and it doesn't hit this because it's open. So it is only hitting one point of the graph at that time. So yes, this is definitely a function. So this one is a function. And then the question becomes, is it one-to-one? And if it's a one-to-one function, then you want to see if it passes the horizontal line test. And so you're going to take your horizontal line, and you are going to see what happens there when you take your horizontal line. So I take my horizontal line. If I were to draw it right there, put my horizontal line right about there, you can see clearly that the horizontal line passes the graph in more than one spot when you put your horizontal line there, so it is not one-to-one. This is not a one-to-one function. Okay? All right, then the question becomes, is this a function? This time I did not give you the graph, and so you're going to have to be able to figure out the graph. You can certainly use your graphing calculator to help you, but if you're going to make the graph, of course, you have to get it solved for y, and so to solve this for y, I would take the square root of x, and of course, when you take the square root, you need to remember that you need to have the plus or minus in front of there, okay? So, you can use your graphing calculators and make yourself a table if you want. If you use your graphing calculators, in y1, you would put the square root of 1, and in y2, you would, or square root of x, and in y2, you would put negative square root of x, because you need both the plus and the minus there, and that's the only way to get it. Okay? So if we think about this, if we were to make our own little table and graph this, I just kind of want you to be able to think about this algebraically, so I'm going to do this one by hand here. If we were to pick some points, so let's say x is 0. Well, the square root of 0 is 0, so I would get 0. Okay, let's say I plug in 4. The square root of 4 is 2, and technically I would either have plus or minus 2. Okay, so actually I would need to have one coordinate where if I plug in x for, or 4 for x, I would have one output where it's 4, or 2, I'm sorry, and one output where it's negative 2. Okay, if I were to plug in 9, the square root of 9 is either positive 3 or negative 3. So you see how you would need both of those outputs. You can't obviously put negative numbers into here. That is not going to work. I cannot put a negative number in here. So the smallest number I can use is 0. And of course you can go from here. So I will have 4, 2, 4, negative 2, 9 and 3, 9 and negative 3. And my graph will look something like this. Okay? So you can clearly see that it's not even a function because unique x's, in other words, when x is 4, produces double y's. Okay? So 4 could either be 2 or it could be negative 2. And when you have one number that generates 2 y's, it's not a function. Okay? Obviously, if you look at the graph, it's not a function either because it does not pass the vertical line test. So no, this is not a function. Is it one-to-one? No, it can't be one-to-one if it's not even a function in the first place. Okay, here's one where we're just going to, it gives you a list of coordinates that you're just going to plot. So if I plot the point 3, 6, obviously that's there, 110, 5, 9, and 12, 7. Would be somewhere like right about there. Okay? Obviously, first of all, you're going to need to determine, is this a function? So does it pass the vertical line test? Can I draw a vertical line anywhere? And the most spots that will cross in is 1. So yes, it's a function. And then, of course, the next question is it one-to-one? And if it's one-to-one, it will also pass the horizontal line test, where every y has only one x to it. So if you look at this, if the number 7 has only one possible x to it, and it's 12. If it did not, then it would not pass the horizontal line test. And of course, you can draw a horizontal line anywhere, and it will only cross in one point. So yes, it is also one-to-one. Okay? So that should help you determine that. All right. Y equals x cubed. If you put this into your graphing calculator and graph it, x cubed will look something like this. Okay, and yes, it passes the vertical line test, so it is a function. And it also passes the horizontal line test, so it is also a one-to-one function. Okay, so this is both a function and a one-to-one function. Okay. All right, now we're going to look at inverses. An inverse function basically reverses a normal function, but in order to do the inverse function, you can only do inverse functions on functions that are one-to-one functions. And if that's not the case, then you kind of have to restrict the intervals that it can happen in sometimes, and we will sort of talk about that, okay? So whenever you see this little f-1 symbol, it means inverse. That's what it means. And here's kind of how you calculate it, okay? To calculate it, what you do is you switch the x and the y's around, and then you resolve them for x and y, okay? And I'll sort of show that now. But first of all, we're going to prove if something is an inverse. And so in order to prove it is an inverse, what you do is you have to find f of g of x and g of f of x. And they both have to have x for an answer, okay? So you're going to plug g into f's equation, get x for an answer. Plug f into g's equation, get x for an answer. If they don't both come out to be x, then they are not inverses of each other. So the question becomes, are these two functions inverses? I'm going to call this one f of x, and I'm going to call this one g of x. Okay? And the first thing I want to find is f of g of x. So basically what that means is I want to take g's equation and I want to plug it into f's. Okay, so I'm going to take g's equation, I will plug it into f's. And so then, to do that, I have x cubed, that's what's going to replace x, to the 1/3 power. And of course, when you deal with your exponent rules, then you would multiply 3 times 1/3, which would just be x to the 1, which of course is x. Then if you do it the other way around, g of f of x, now you're going to take f's equation and you're going to plug it into g's. So of course, I would take x to the 1/3 to the 3, and again, using exponent rules, I will multiply those two exponents, and I will get x to the 1. Okay? Are these inverses? Okay, so again, I will call this f of x and this g of x. And if I find f of g of x, I'm going to plug g into, I'm going to take this equation and plug it in here. Okay? Well, when I take that equation and plug it in there, then I get 1 over x. And 1 over x does not equal x. So no, this is not an inverse. Okay? These are not inverses of each other. All right, and then if we do this one, again, f of x, g of x. Okay, I will take this one first of all and plug it in here. So when I do 3 times x over 3, I, of course, those drop out and I get x. And then I will do it the other way around, where I take this one and I plug it in here. And then I get 3x over 3, which of course is also x. Since they both equal x, I have x here and I have x here. When you plug one into the other, they both have to equal x, not just one. Then yes, these are inverses of each other. Okay? So that's how that happens. All right, then sometimes you need to be able to find inverses. And in order to find inverses, what you do is you interchange the x's and the y's, and then you resolve for y, and then you have to prove to me that they're inverses by finding f of g of x and g of f of x. So it's kind of a process, but we can do it, okay? So, of course, you're going to treat this like your y, okay? So you're going to treat this like your y. So if you rethought of this as this, okay, I still have the same equation. So the first step in finding the inverse function is to switch the x's and the y's around. So when I switch the x's and the y's around, it would look like this. What was a y becomes an x, and what was an x becomes a y. So that was step number 1, interchange the x's and the y's. Okay. Step number 2, solve the new function for y in terms of x. Okay. So if I solve this equation for y right here, of course I will subtract 4. So I will have negative 2y equals x minus 4. And then I divide by negative 2. So y will be x minus 4 over negative 2, that whole thing. Okay, now instead of calling that y, this is your new y now, you are going to call this the inverse of x. Okay, and then what you need to do is that you, so this is the inverse, and now I want you to prove to me that they are inverses. Okay, so here's what you're going to do. You're going to take your two equations and plug them into each other. Okay, so the first thing you're going to do is you're going to take this one right here and you're going to plug it in to the original right there. So you will have negative 2 times x minus 4 over negative 2 plus 4. Okay, and those two will drop, and then I will have x minus 4 plus 4, which of course is x, and that's what I want. I want it to be x. And then you'll do one where you go the other way around and you take your original equation and you plug it in to the inverse. And you will go negative 2x plus 4 minus 4 over negative 2. Of course, the 4 minus 4 makes 0. And then the negative 2's will cancel. And again, I get x. So these really and truly are inverses of each other. It's all good and dandy. Okay? All right. And if we think about the original graph, the original function, the original function is a line because it's negative 2x plus 4, and there's no, all reals for your domain and for your range, so there's no restrictions that I need to make on that. Okay? Now, here's your next one. I am telling you this because if we were to graph x squared plus 1, and if you were just think about this, if we were to graph x squared plus 1, x squared plus 1 is a parabola, just so you know, that looks like that. And that parabola is a function because it passes the vertical line test, but it's not a one-to-one function because it doesn't pass the horizontal line test. So what I'm telling you is that you can only find the inverse for x values that are greater than 0. Because if I look at just this part of the graph then, where the x values are greater than 0, now not only do I have a function because it passes the vertical line test, but I also have a one-to-one function because it passes the horizontal line test now as well. So I'm just going to keep this picture up so that it kind of helps us. But again, you're going to think of this as y equals x squared plus 1. And then, of course, you'll switch your x's and your y's around. So when I switch my x's and my y's around, then I have x equals y squared plus 1. Resolve for y. So I have y squared equals x minus 1. And of course, you'll take the square root of that. So y will be positive or negative the square root of x minus 1. That is the inverse to that. Okay? Now, the question becomes, what kind of a restriction do you have to put on the inverse? Okay? So remember that you can't take the square root of negative numbers. I cannot take the square root of negative numbers. So when I take the square root of negative numbers, then you need to remember that your x values here have to be greater than or equal to, the smallest number you can take the square root of inside here would be 0. So your x values have to be greater than or equal to 1. I couldn't plug in 0 for x because 0 wouldn't work. Okay? So that is not going to happen. So this is your inverse. But again, you have to restrict your intervals so that your x value can only be greater than or equal to 1. Okay? So here we go. Now we're going to plug the two equations into each other. Okay? So first of all, I will take the original equation up here, and I will plug her in down here. Okay? And when I take the original equation and I plug it in, then I have the square root of x squared plus 1 minus 1, which of course is the square root of x squared, and then those two undo each other, and you just get x. Okay? When you go the other way around, you will take this one, okay, and plug it in here. So then I have the square root of x minus 1 squared plus 1. And when you square a square root, that just undoes itself. So I have x minus 1 plus 1, which of course just comes out to be x. And so they both come out to be x, and they are, it is possible then for them to be inverses, okay? And again, instead of calling this y right here, this is the inverse. So you should actually call this f negative 1 of x equals the square root of x minus 1, but x has to be greater than or equal to 1. Sometimes you have to put some restrictions on there because you can't plug in negative values underneath the square root. Okay? So, there we go. That'll do it for you, and we'll be back.